Assalamualaikum and hello everyone. Welcome to Group 2 presentation. In this video, we're gonna present and explain about ground canalulated blast furnace link, GGBS, the sustainable construction alternative. First of all, let me introduce myself and group member. I am Amira Akila and my other group member Muhammad Alif Iqmal Hakim, Valentine, Jovita, and Noraida Usna.
Hi everyone, my name is Noraida Usna and now I want to present about introduction of GGBS. Ground granulated blast furnace slag or GGBS is a cement-based material mainly used for concrete and is a byproduct of the blast furnace used for steelmaking. GGBS can also be obtained by quenching molten iron slag from a blast furnace with water or steam to produce a glassy granular product, which is then dried into a fine powder. Due to the large amount of building debris and slag sand available in Turkey, it makes economic and ecological reason to use these materials as aggregates to produce a more durable concrete mixture. The main focus nowadays is on the search for waste or byproduct from the manufacturing process that can be used as a partial replacement for cement in concrete without compromising the desired strength. The ratio of water to aggregate to cement term in the mixture remains unchanged. The exchange level of GGBS varies from 30% to 85%. Usually 40 until 80% is used in most cases. The use of GGBS in addition to Portland cement in European concrete is regulated by Concrete Standard EN 206 2013. The blast furnace operates at a temperature of approximately 1500 degrees and is supplied with a carefully controlled mixture of iron ore, coke, and limestone. Iron ore is reduced to iron to the rest of the material from slag that float on the iron. This is typical chemical composition and typical physical properties.
Hi, I am Jovita Tan. Now I will talk about the literature review of our project. First, in this research article, the strength development of mortar containing GGBS and Portland cement was investigated. From this article, we can know that the variable of the amount of GGBS in binder are the water to binder ratio and the curing temperature. According to this research article, we focused on the efficient use of waste material as a partial replacement of cement and sand in concrete manufacturing. From this research article, the slight influence on cracking was determined. As the result, slag cement concrete cracked later than the Portland cement concrete. According to the review, GGBS were found to improve the property of concrete at a later age when subjected to replacement level. This research article studied the effects of the curing method on the development of compressive strength in the cement mortar and concrete containing GGBS. According to the finding of this article, the characteristics of GGBS are high strength, low hydration heat, and chemical corrosion resistant. That's all for my part. Thank you.
Hello, my name is Valentine. Now I will present to you the discussion and results that we obtained from our project regarding the use of GGBS in concrete. As we know, GGBS have advanced durability properties such as high resistance to sulfate attack, high resistance to alkali silica reaction, and high corrosion resistant. These are the properties of GGBS, both chemical and physical. GGBS is made up of calcium oxide, sulfate, and alumina. It is in pale white in color. It has 2.7 specific gravity and 1,160 kg per meter cube of bulk density. Table 2 and Table 3 shows the composite strength of concrete in M20 and M40 grading. According to the research by Santosh Kumakari, we can see that the higher the percentage of GGBS in concrete, the higher the compressive strength of both graded concrete that contain GGBS after 28 and 90 days. Table 4 and Table 5 here shows the split tensile strength of concrete both in M20 and M40 grading. Also, according to the research by Santosh Kumakari, we can see that the higher the percentage of GGBS in concrete, the higher the split tensile strength for both graded concrete that contain GGBS after 28 and 90 days. Alright, now we observe the effect of variation of GGBS on compressive strength. About 40% replacement of cement with GGBS, M20 and M40 grade concrete attains its maximum compressive strength. When the replacement exceeds 40%, we can observe that the compressive strength for both graded concrete to be decreasing slightly. Here, we also observe the effect of variation of GGBS on the split tensile strength of concrete. After 40% replacement of cement with GGBS, M20 and M40 grade concrete attains its maximum split tensile strength. When the replacement exceeds 40%, we can observe that the split tensile strength for both graded concrete to be decreasing slightly. From this figure, for about 30% replacement of GGBS is greater than 50% replacement. Regarding the effect of temperature on cracking risk of GGBS concrete, this test was assessed by using UTHM shrinkage ring test method. At standard curing temperatures, all concrete took a prolonged period of time to crack. As the curing temperature increased, the cracking risk of the mixes also increased. This table shows the cracking risk of different mixes under different temperature. Ordinary Portland cement (OPC) shows higher cracking risk than GGBS concrete under high temperature. As we can observe from this table, OPC have higher cracking risk compared to 35% to 70% of GGBS concrete under 50 degrees Celsius, which only achieve moderate high cracking risk. That is all from me. Thank you.
For the conclusion, GGBS have a good workability. It is because the workability is increased with increase of GGBS in concrete. Next, it can be reducing compressive reinforcement, as well as the maximum compressive have been achieved for replacement is 40 to 45 of GGBS. Last but not least, the split tensile strength increased with increased percentage of GGBS at later age. As you have seen, GGBS is a good replacement to cement in some cases and serve effectively, but it cannot replace cement completely. Even though it replaces partially, it gives a very good result and greener alternative for construction, which we as engineers are keen about today. That's all from our presentation. Thank you.